Right, we might get kicked off today. So thank you all those who have come in on time, and I know there are a few more will probably pop in during the discussion. So good morning, my name is Nikki Ford. I'm the CEO of Australian Organic, or we're more commonly known as AOL. Thank you to everyone who's joining us today. We have a very diverse range of people on the webinar, which is quite an interesting representation of exactly what the organic industry is all about. I guess before we begin, I'd like to acknowledge the Turrbal people, the traditional custodians of the land on which I meet with you today, and pay respects to their elders past and present. I extend that respect to Aboriginal and Torres Strait Islander people here today. I'll make firstly special mention of AOL's Bud licence partners and members, for without the ongoing support of these operators, organisations and individuals, events such as today would not be possible. The organic industry in Australia is still to fully reach its potential, with much work still being done when it comes to the regulatory framework, market access, consumer education and research. And more than 3 years ago, AOL demerged from its certification subsidiary ACO Certification Limited to embark on the journey to assist our industry to evolve to that potential. Part of that journey involves investing in Australian-based research. And a little over 2 years ago, AOL began discussion with Australia's #1 university, the University of Melbourne. And today we will take you through the very first research project we've been partnering with the university on, a review on the benefits of the probiotics in organic food. More research will be undertaken in the coming years. However, the encouraging findings will be presented to you today. Firstly, I'd like to introduce your panellists today. Josephine Pedersen, who is our Technical Officer here at Australian Organic Limited. She's got a Master's of Science, Organic Agriculture, majoring in agroecology for Wageningen in Holland. And she also has experience in organic farm management, both in Australia and Europe. We have Dr Senaka Ranadheera, who's a lecturer of the University of Melbourne with a PhD in dairy microbiology, and has previously lectured at the University of Sydney and Victoria. We have Anna Wittwer, who has a Bachelor of Science with a degree in honours in food microbiology. Is current PhD candidate and has previously been a researcher for the research assistant, for the University of Melbourne. So I'll now hand you over to Josephine.
Thank you very much, Nikki. So I'm sure that, if you're here at this webinar today, you have quite a good understanding of what organic means. But for those of you who don't, within cropping and horticulture, organic means no artificial fertilisers, harmful synthetic pesticides, no GMOs. There's a minimised risk of, toxic chemicals leaching into waterways, as they're not allowed within organic agriculture. So compost and soil fertility is the main source of plant nutrition rather than mineral nitrogen fertilisers. And you're aiming for a higher biodiversity and more of an integrated pest management system so that you have reduced needs of inputs. So for livestock, again, no antibiotics, no chemical anthelmintics, growth hormones or growth regulators. Animals are fed organic feed and they're free to roam. You're not allowed to livestock or finishing within organic livestock. There's a lower animal density per hectare compared to conventional, and the soil is tested for maximum residue limits. The feed is tested for pesticides, and you have this whole system where we're trying to ensure that the animals live a free, natural life and eat food that hasn't been treated with any chemicals that you wouldn't want in your body. In terms of the current situation, over 900 agricultural and veterinary chemicals are approved by the Australian Veterinary Institute. And so these come under synthetic fertilisers, pesticides, fumigants, all of these products. They typically have withholding periods, but even with withholding periods, there's always the chance that some of that will potentially be on your food. And in terms of the Food Standards Australia, within organics, the maximum residue limits are 10% of what the Food Standards Australia and New Zealand have. So if you have an organic product that is tested, Normally, the maximum residue limits definitely don't reach the maximum allowed for fazans, but even so, when they are tested, your organic products needs to have 10% or less of that allowed for fazans to be passed as an organic product. And with that, you know, in the organic industry, there isn't that much research within Australian organic conditions. So as a peak industry body, we have a lot of questions about, is there a quantifiable difference in the nutritional value of organic food? So within Australia, we have very different soils to the rest of the world. So this is really something that we are wanting to work on going forward to justify with peer-reviewed evidence potentially what the effects of vegetable and livestock production under organic conditions actually means for you and your health as a consumer. So with collaboration, we have partnered with the University of Melbourne, and it is with my pleasure that I introduce to you Dr Senaka, who will be taking you through the basis of the background of the research that they have done. And without further ado, Senaka, please tell us more.
Thanks, Nikki, and thanks, Josephine. Really grateful to be here today. So I'm going to introduce a little bit about human gut microbiome and how our diet can influence the composition of this human gut microbiome. Next slide, please. Usually, you might heard gut microbiome is microorganisms that live in our gut system. At birth, our digestive system is usually sterile, mostly sterile, but with short period of time start to become colonized. At the moment, research says that we do have more than 100 trillion types of microorganisms in any individual's digestive system. And this consists with more than 500 species and mainly bacteria. They perform really important function in our body. For example, they defend against pathogenic microorganisms, especially gastrointestinal related pathogenic microorganisms like salmonella. They help in digestion and also nutrient absorption. They produce certain vitamins which are very important, like vitamin K and B, B complex vitamins, and also many reports indicated that they boost our immune system as well. Next slide, please. This is another very important thing when it comes to the gut microorganisms or gut microbiome. They are very unique to any individual, unique as their fingerprints. Their composition, however, can be vary with many different factors. So I have listed few in here. Number one would be the composition of our mother's gut microbiota. The way we are born is also another important factor, whether it is a vaginal or cesarean delivery. It says that those who are born naturally through the vaginal delivery has more healthy and high diversity in gut microbiome. Our early diet, especially breast milk contains some important components that need to develop healthy gut microorganisms. That's why I think another important reason for breastfeeding of young kids in their early ages. And also our first formula diets or first diet can also have significant impact on the composition of our gut microbiome. Early life events such as certain diseases, stressful conditions, use of antibiotics and several other medications, condition and environmental factors, they all affect on our composition, different composition of the gut microbiome in our system. Around the age of 3, the gut microbiome starts to stabilize and its evolution anyway continues at a steady rate during the adulthood as well. Next, please. Now, I would like to introduce another important concept, another important topic on probiotics, because probiotics affect the gut microorganisms. Probiotics are basically live microorganisms, mainly bacteria. When we consume alive in adequate or the sufficient amount, can confer health benefits on host animal. You might heard about lactobacillus or certain microorganisms in famous fermented food products. So lactobacillus and another type of bacteria called bifidobacterium, they are the most common probiotic microorganisms. They help to colonize the gut microbiota with the beneficial microorganisms. That's why probiotics is very important, and they have a relationship between our gut microbiota. These concepts of probiotic was first proposed by a Russian-born scientist who worked at a Pasteur Institute in Paris, Professor Elie Machinov, in 1907, because he observed the longevity in Bulgarian people who consume fermented milk products at that time, and he started research on that observation, and finally he came up with this concept of beneficial microorganisms. Actually, I need to stress that this concept of probiotics is quite new, but as humans, we have been consuming these beneficial microorganisms in the form of fermented food products for many thousands of years. Next, please. These probiotics also, in association with gut microorganisms, provide many health benefits for the consumers. Some of these benefits are listed here. Of course, they help to maintain a healthy gut microbiome. They also enhance, boost our immune system. They are really good to treat and provide some remedies for gastrointestinal system related disorders like IBD, IBS, conditions like lactose intolerance. Other than that, they do have anti-carcinogenic activities. They also help nutrient metabolism, and also especially good in giving some relief for some allergies, symptoms of allergies like asthma and eczema. Next one, please. Just wanted to give you a brief idea about probiotic food products, especially the market growth. This is a multi-billion dollars worth of industry, and it is expected to reach US dollars 76.1 billion by 2027. Another important factor with this market growth is it is expected that Asia Pacific region is going to play a key role in probiotic market. So it is particularly important for us because we are also living in Asia Pacific region. Probiotics can be found as formulations, capsules, nutraceutical industry as well, very profitable business at the moment, and also fermented food products. There are several different probiotic food products, many ranges available throughout the world. However, the main consumption method is fermented food, in particular fermented dairy food products, yogurt and cheese. They are the main food products available at the moment as main probiotic food products. However, there's an increasing demand these days, and it is going to be like that for next couple of years as well, for non-dairy probiotic food products from vegetarians and vegans with the development on vegan and vegetarian tastes. Next one, please. Another important thing when it comes to probiotic is we need to consume them at a minimum level. There's a recommended minimum level, and if we do not consume that recommended minimum level at the time of consumption, if we do not have that level, which is 1 million to 1 billion, viable live bacteria per gram of, or the milliliter of the carrier food product, we won't be getting that said health benefits. So it is important that we consume them at a live state. It is because these microorganisms need to go through our digestive system and attach into the epithelium, gut epithelium, especially in the lower gut, lower intestine, which we call colon area. If they do not attach into the epithelium of this colon area or the lower gastrointestinal tract, which most of our gut microbiome can be found, we won't be getting any health benefits. That's why it is important to consume these recommended levels at the time of consumption. Next one, please. That is why it is a big challenge, the probiotic delivery, probiotic production of probiotic food products. It's a big challenge because they need to pass through our digestive system. Other than that, these microorganisms are very sensitive. They are not robust microorganisms like the pathogenic microorganisms, and they easily destroy during processing, transportation, and storage, and so on. And many of the environmental factors can affect on their live status as well. And also all these beneficial pathogenic microorganisms mostly are anaerobics microorganisms, which means they prefer oxygen-free environment. So it is very difficult to provide all these good conditions for these microorganisms. That's why it is challenging to produce good probiotic food products. The other major challenge is, as I mentioned earlier, our digestive system, especially our gut, is acidic in nature because it facilitates the digestion, and also our small intestine, the upper part of the small intestine contain many enzymes and also bile salt. So these are detrimental for these live microorganisms. Next one, please, Josephine. It's the same thing which I explained previously, and you can see some of the examples of these microorganisms which live throughout our digestive system. Usually, microorganisms like lactobacilli can be found in the upper gastrointestinal tract, stomach area as well, because lactobacilli is quite acid-tolerant microorganisms compared to other probiotic microorganisms. However, the upper gastrointestinal tract, the pH can be as low as 1.5 to 2, which is highly acidic in nature. So most of these microorganisms cannot survive. That's why we need to have sufficient amount when we consume them. At the time of consumption, if you get this 1 million to 1 billion per milliliter or gram of carrier food product, that, you know, the magical number, there's a guarantee that certain microorganisms can survive through this harsh system and can attach and colonize into the gut epithelium. So in that way, they became a part of the composition of the gut microorganisms, and they can provide all these health benefits for the consumers. Next one, please, Josephine. This is just to show you how these probiotics microorganisms can attach into our intestinal epithelial cells. Some of these photos were taken by me, actually. These are in vitro conditions, which means, you know, we mimic the gastrointestinal system in test tubes in our laboratory using some tissue culture techniques and growth of the human epithelial, intestinal epithelial cells. As you can see in the picture to my left, B, you might see some rod-shaped, long, you know, bacteria attached into the epithelial system. In all other pictures as well, you can see this condition clearly. So this is sort of a, you know, in vitro condition or mimic condition, how our gut epithelium looks like with these gut microbiome or probiotic microorganisms. Next one, please, Josephine. With the probiotics, there's another term that we definitely need to discuss, which is prebiotics. Prebiotics are basically food for the probiotics. Prebiotics are basically undigestible plant fibers, such as inulin-type fructans and certain oligosaccharides. So we consume them with our food. We cannot digest these components, which is prebiotic components, but when these components reach into our digestive system, especially the lower part of our digestive system, they provide food for our gut microbiome as well as probiotics. So they can sort of boost their interaction and also provide good effect for us through consumption of prebiotics. So it is not necessary for us to always consume probiotics, but if we consume prebiotics, especially plant food products are rich with many prebiotics, very good prebiotic components as well. So if we consume this prebiotic component, that provide a good beneficial effect for our gut microbiome. Next slide, please. Some of the food, quite familiar, and we can easily incorporate into our day-to-day life, day-to-day diet very easily. Some of these food products, these are very high, rich in prebiotic components. And there are many other food products as well, but in particular, many fruits and vegetables are rich in these prebiotic components. Next slide, please. Here's a very interesting story, a study conducted by Professor Tim Spector, who was a professor at the King's College, London. He was particularly passionate about these gut microorganisms and health effects of these gut microorganisms. So as I remember, in 2014 to 2017, he conducted many research related to these gut microorganisms and prebiotic, probiotic rich food products. So one of these interesting studies was he spent 3 days in Africa. I think, as I remember, it's Tanzania, with one of the only few hunter-gatherer tribes which we have at the moment in our world. So he spent 3 days with them and performed intensive 3 days of eating like a hunter-gatherer. So after 3 days, he returned to the lab and they analyzed his gut microorganisms, and they found that a very significant increase in the gut microbial diversity. It is actually 20% increase more towards the healthier microorganisms, only after 3 days of eating like a hunter-gatherer. But the bad news is, after a few days, they checked his gut microbiome, analyzed his gut microbiome again, and they found that it returned to where they were before. So there's a key message in this study. One is current Western diet, which is rich in a lot of sugars and fat, is not healthy towards our gut microorganisms. They do not provide beneficial effect towards them. We need to incorporate food, especially fruit and vegetables, that produce as natural as possible, closer to the we can't really get the hunter-gatherer's food, but the food that produced in a natural way can provide beneficial effects towards our gut microorganisms. The other thing is we need to regularly intake this healthy food, because the probiotics or prebiotics cannot reverse our gut microorganisms into a health system forever. That's the way it is. We need to consume them regularly. We need to provide good food, natural food products for our gut microorganisms. And in that way, they can enhance our gut microbiome. Definitely, we need more research in this area, but current evidence is sort of promising. And we recently performed an systematic review with the help of Australian Organics Limited, and our findings look promising, but we can't exactly say, organic was versus non-organic, whether it is significantly beneficial for our gut microbiome or not. But the current results look promising, and we really look forward to do more research in this area next few years. Thank you.
Thank you very much, Senaka, for that introduction. I'm now going to talk a little bit about the research that Senaka just mentioned. I don't think I have. Yeah, that's all good. Next slide, please, Josephine. I'll kind of get straight into it. I'll start with the research question that we based our study on. And that was initially, we wanted to know whether organic foods have a different effect on the human gut microbiome from non-organic foods. We unfortunately didn't find any research that had directly measured changes in the human gut microbiome in response to an organic diet. But that may be, I guess, a silver lining, which we'll kind of return to later. For the purposes of this study, we then kind of pivoted to looking instead at whether or not organic agronomic management practices influence aspects of food that can in turn influence the human gut microbiome. Next slide, please. To answer that question, we performed a systematic literature review. We developed a string of search terms, and we applied that string to multiple different databases. This review was quite broad in nature. We looked at 6 different categories of food. We looked at meat, grains, dairy, fruits and vegetables, grapes and wine, and fermented foods. The results that we got, we then screened the titles and abstracts of the hits using a collection of inclusion and exclusion criteria. Next slide, please. This is a flowchart that summarizes that process. You can see that we went from over 6,000 initial records to just over 200 that were included in our final review, split across 6 categories. We used quite a simple scoring system on each paper. What we wanted to know, that the information that we wanted to extract, was whether or not nutrient levels were increased, unchanged, or decreased in organic products relative to non-organic ones. It's worth mentioning here that we only accepted what we would call comparative studies. We were only interested in studies that were actually controlling that had the only thing different between 2 sets of food be the organic status of the food. Next slide, please. Overall, we found that nutritionally, organic foods are different from non-organic foods. That's not to say that they're universally always going to be more nutrient rich than organic foods, but we did find that that was the truth in some cases. The next kind of set of slides is going to be some notable results that we found within each of the different food categories. So we'll go through that now. What we have here, just to explain the graphs that are going to be on the next few slides. On the y-axis, we have the number of studies that reported a certain result. And on the x-axis, we have the specific food that the study was about. The legend that we have on the right is hopefully fairly self-explanatory. It's kind of a traffic light-esque system. Carotenoids, as the name suggests, I'll just briefly define these. They're found in carrots, but they're also found in a lot of other fresh fruit and vegetables. They are yellow, orange, and red fat-soluble pigments that also act as antioxidants. Flavonoids are also antioxidants. They're a class of polyphenols that are named after flavone, which is a molecule they're all structurally similar to. So you can see that generally for flavonoids more than for carotenoids, these antioxidant compounds were enriched in organic fresh fruit and vegetables compared to non-organic fresh produce. Next slide, please. After this is kind of the, if you remember the flowchart, the little flowchart that I had before. The second half of our question, I guess, after establishing a nutritional difference in organic foods, was then to connect that difference to an effect on the gut microbiome. So these slides answer that part of the question. Carotenoids, I know Senaka covered prebiotics quite extensively before. They are not the only things that can modulate the gut microbiome. Diet appears to have quite a holistic effect on the composition of our gut microbiome. So carotenoids may be actually directly consumed by members of the gut microbiome, but that hasn't been directly shown. The, I guess, more interesting result with carotenoids is that they can alter immunoglobulin A expression, which is very important for bacterial colonization. And Senaka mentioned that that is particularly important for probiotics to adhere to the intestinal epithelium. For flavonoids, they have a kind of a double-edged effect on the gut microbiome. They not only inhibit the growth of various undesirable microorganisms, but they promote the growth of desirable organisms like bifidobacterium and lactobacillus. Next slide, please. We weren't just interested in the good things that food can deliver, we were also interested in things that we don't necessarily want to see in food. Environmental heavy metals like lead, chromium, arsenic, I believe fairly well known to be pretty bad for you. Pesticides, many different types, obviously, but in general, it's any substance used to destroy anything considered a pest. The studies that we reviewed fairly consistently found levels of these harmful compounds to be reduced in organic fruits and vegetables. The pesticide result we expected because, as Josephine mentioned earlier, that's kind of I guess, a central tenet of organic management. The heavy metals, you might notice that there are there's some blue in there. That's not necessarily an indication of anything really to do so much with organic management. Heavy metal contamination is very highly linked to geography and environment. Also, it has the heavy metals tend to stick around for a really long time. The studies that we looked at were from all over the world. So not every place has the same standards as here. It's just, yeah, that's kind of an explanation for why the result is a little bit more mixed than you would think. Next slide, please. As I mentioned, heavy metals are kind of known to be generally pretty bad for you, but they also have direct effects on your gut microbiome. They can perturb or unbalance the composition of your gut microbiome, and they also can contribute to the progression of various metabolic diseases. Pesticides, as I mentioned, there's many different types, and the specific kind of pesticide is going to determine the specific effect that is seen on your gut. But in general, they can cause dysbiosis. Dysbiosis is just a term for a lack of balance in the composition of your gut microbiome. And they can also potentially cause pesticide-induced toxicity. Not good all around. Next slide, please. For fatty acid profiles of dairy and meat, you'll notice on the right that our kind of scoring system is a little different from the previous two graphs that we had. Here, we weren't looking at an increase or a decrease. We were just looking at different and not different. That was done for mainly for the reason that fatty acids, we would be looking at kind of tens of compounds that individually are kind of present in micronutrient quantities. It isn't feasible to look at them all individually, but we can assess whether the overall collection has been influenced. And this is, I think this is my favorite result. This was the one that I don't think I was expecting this. Apart from, I think, 1 or 2 studies on bovine milk, all of the research that we surveyed found that the fatty acid profile of dairy and meat, of organic dairy and meat, was different from non-organic dairy and meat. Next slide, please. Evidently, there's, as I just mentioned, there's lots of different types of fatty acids, and a change in fatty acid profile can mean all sorts of things for specific fatty acids. But one particular effect that we just wanted to focus on today was an increase in polyunsaturated fatty acids. This is commonly associated with things like grass feeding, essentially the diet of ruminant animals has been shown to strongly affect the composition of the milk they produce and even meat as well. Polyunsaturated fatty acids in individuals with IBD, which Senaka mentioned before, polyunsaturated fatty acids positively affect microbiome composition. And in general, in all individuals, they have been shown to increase short-chain fatty acid production. That's an important metric of gut health. Your gut microbiome produces these fatty acids in an ideal situation. Next slide, please. The last kind of collection of notable results is for antioxidant activity and phenolic compounds in wine and grapes. Phenols are a particular class of antioxidants that are named for their chemical structure. These trends are, as you can see, a little more ambiguous than previous trends, but I still think it's very interesting, particularly with the graph on the right, that organic wine appears to contain a greater concentration of phenolic compounds than non-organic. I also find it kind of curious that this wasn't observed in grapes, so that possibly indicates that the fermentation process of turning grapes into wine is related to phenolic content. So that's interesting. Next slide, please. I think we all, from a lot of the marketing we get, we know that antioxidants are good for health. They're often marketed in things like even skincare. But in the context of the gut microbiome, they remove potentially damaging oxidants, which can have all sorts of deleterious effects in the gut. Phenolics can alter microbiome composition through both, I would describe it as a prebiotic effect, so selectively feeding desirable microbes, and also through antimicrobial effects against pathogens. So a similar two-sided effect to what we saw earlier with flavonoids. Next slide, please. That brings us kind of to the end of the results section of this presentation. This flowchart summarizes all of the results that we've just gone into in a lot of detail. It's, I think, a nice reflection of the way that we structured our research question and the output that we've got. Next slide, please. Before I go into kind of the final conclusions from this research, I just want to talk a little bit about the limitations of this study. Every study has some limitations. I mainly want to talk about the last point on this slide, and that was that the scoring system that we use doesn't take the size or the magnitude of the difference between organic and non-organic foods into account. That was the best decision for a project of this scope. We covered a very broad range of foods, and that necessitated a certain approach, but this last limitation is something that I would say needs to be taken into consideration for further research in this area. Next slide, please. So that brings us to the end of my part in this presentation. Gut health and the gut microbiome it's a really exciting area of research. We now know more than ever that the gut is crucial, not just to areas of health that you might expect. For instance, the composition of the gut microbiome has been implicated in obesity and the development of various metabolic diseases, but it's also been linked now to neurodegenerative disorders and things like Parkinson's disease, which I think is quite amazing. So we now know that the gut is, there's all sorts of buzzwords and terms that go around. We talk about the gut-brain axis now and a second brain in your gut and all sorts of things, but it's a burgeoning area of research. But nobody has yet really directly looked at changes in the gut microbiome in response to organic foods or an organic diet. And we think that this gap in the research is a really, really exciting opportunity for further studies to directly kind of dig into this new area. That's all from me.
Thank you, Anna, Senaka and Josephine, for the really informative presentation. I did send everyone a message in the chat box earlier to say please put your questions in the Q&A or chat, and we'll get to them at the end. And there is one here already, Anna, it's for you. It said, I'm not sure which slide it was referring to, but it says the slide is not being very clear as to what is being compared to. Simply states fresh produce. Could this be clearer?
I'm going to assume that I had 2 slides about fresh produce. Josephine, would you be able to go back to, I'll say stop, maybe the one previous? One more. The comparison here, so I think I mentioned earlier, it's a good question actually. I think I mentioned earlier that the only studies that we accepted into this review were comparative studies. So when I say increased, decreased, unchanged, what I mean is that the comparative study of, let's say this one here, apple, on the lower left of the flavonoids graph, that study was comparing organic and non-organic apples, and it was looking at the quantity of flavonoids in those fruits. Hopefully that answers that question. Yeah, some additional words. Yes, that's completely fair enough. It's yeah, a little bit tricky trying to squish that much information into one graph, but hopefully that clarifies things.
We've got a couple of comments in chat. So got a message. So hopefully, Annie, that was your question. If that hasn't clarified, please let us know and we can go into further detail while we've got Anna. We've got a message here from Carolyn that says, great presentation, would be really interested in further research in the dairy sector, RE healthy benefits of grass-fed dairy separate to organics. Lillian has also sent a message that said, that was my question too. I think we just need to some additional wording on this slide. So if someone saw it, it said certified organic fresh produce XXX. Got a couple of extra messages.
Nikki, can I just make a comment on those Caroline and Lillian's messages?
Absolutely.
They capture a really interesting area actually, and you can explain later as well. We found quite a significant difference in dairy, organic versus non-organic food product. So out of this research work, actually we produced a review article which will be submitted to a journal at the end of this month, most probably, and there'll be a review. We can share our findings with you all when it is published.
Great, thank you, Senaka.
Thank you.
Yeah, just to go further from what Senaka said, the graph that's on screen right now, that was really exciting for us to see. So that was what prompted us to go further into the dairy aspect of things. So yes, it'll be very exciting once that review is hopefully accepted. I think there was a question from Lillian talking about fresh produce. You might have caught on the slide that I had about limitations. One thing that I noticed when I was reviewing these papers was that the methodology is quite heterogeneous. There's quite a lot of variation. There was a supplementary document that we prepared where we kind of pulled all of the methodology information out of the papers. So to answer your question, some were straight from the farm, some were from a supermarket. We did identify a difference between kind of supermarket and farm studies, but I guess the variation was kind of so great that it was not feasible to incorporate that into this aspect of the review. So I hope that answers your question.
Thanks, Anna. Andrea's got a question here too. We're really interested in any studies done on olive oil. I'm not sure if you know of anything specifically on olive oil, Senaka or Anna.
I'm sure we didn't find anything related to olive oils in particular at the moment, but that's why we wanted to cover a vast range of food products in our next few years with this research, organic versus non-organic. We can definitely look into this sort of aspect with different commodities for sure.
Great, thank you, Senaka. Carolyn's got a further question. I think this might be for Josephine. Josephine, have you read the question, or would you like me to read it out?
Yeah, so in terms of who advocates to increase the allowable chemicals, I believe that the Australian Institute of Pharmacy and Veterinary Medicine, they have specialists on site that do allow, that approve the new use of chemicals as such. That doesn't have that much to do with organics, because a lot of the chemicals that they approve, you know, aren't allowed within organic agriculture or farming systems. So in terms of what we do to advocate at this point in time, I understand that, you know, these chemicals are approved for conventional systems. It has been for a longer period of time that chemicals that do have, you know, heavy metal residues within general agriculture aren't getting as much approval as such, and anything that is allowed within and allowed input within organics is not allowed to be residual within the system as such. So at the moment, yes, it's 10% of faisans. I think that what you have to remember is that a lot of organic farms don't actually get up to 10% of what is allowed within faisans. This is just, you know, a general limit. And also when it comes to heavy metal residues, you know, they do stay in the system, and there are protocols in place where, you know, even if there is less than 10%, this might then go on and tested. The heavy metal residues might also be tested in the plant leaf to make sure that even if there is some in the soil, that this isn't coming into your organic product that you are eating, even if it is less than 10% of what faisans allows. So within organics, I really think that we do have the framework to make sure that consumers are actually getting what they're buying for, especially within certified organics.
Thanks, Josephine. There's no more questions currently in the chat box. Hang on a minute. Sorry, there's a couple in the Q&A.
Yeah, I'm just looking at those at the moment. I think I might be able to speak about Eliza's question. In terms of whether I think there's anything we can claim based on the study given its low research numbers, this is digging into some old knowledge of mine. I believe faisans has fairly strict specifications on what can and can't be claimed as part of marketing. I'm not across the specifics of that, so I can't really say if our research lives up to those rules. As I think we've kind of sort of said this, mentioned it in the presentation a few times. I think that the leading outcome we found from this research was that it had identified quite a significant gap in the research that we would we're interested in seeing filled by further research. So I think that hopefully covers your question. I've also seen another one from Annie. In terms of the availability of the presentation, I think Josephine and Nikki can speak about that. But you also asked about tomato. There were a couple of mentions of tomato. Josephine, could you please go back a few slides to the flavonoids and carotenoids slide? Tomato was mentioned on both of these graphs, actually. More flavonoids in the 4 studies about tomato, and more carotenoids, and the further 5 studies found no difference. There were actually, no, it's funny you mentioned that. I noticed there were a lot of papers about tomatoes, so I believe that if you were to look, you would find quite a lot, because there were lots of also different varieties of tomatoes mentioned as well. So yes, there is a lot of research about tomatoes.
To answer Annie's question, Annie, the actual full literature review is available in the member portal under the AOL to AOL members. So it is currently sitting there if you want to go and access it. We would need to chat to the University of Melbourne about sharing it more broadly than that, because at the moment I think it's going through other processes. I think Senaka might be able to share that level of detail.
Yeah, I think, we really look forward to work with Australian Organic next few years to find some of the real answers for these questions. So at the moment, all I can say is, we need to do a bit more research in this area. So it's great that Australian Organic is supportive, and we can probably continue our research work next few years in this line. We are happy to share with the presentations, and also we do have another article on pursuit article, and also bite-sized lectures based on these studies. And so we would like to share those links with Nikki and Josephine, and if you think it's appropriate to share with our audience, definitely, we can do that. And yeah, this is really great ideas actually from the members in the audience, and really fascinating to see this great interest. And yeah, if you have any idea on this work, and if you would like to incorporate any particular food products, please get back to us through Nikki or Josephine or our colleague Simon research work as well. So somehow get back to us, and we would like to hear from you guys, definitely.
Thanks, Senaka. You broke up a little bit through that process, but I think what we heard you say was that you'd love to continue the research. There's certainly more to be done, and love to continue the discussion. We are definitely continuing the work with the University of Melbourne, and again, this is the work we do with them is really very much thankful to all the operators that license the bud and support AOL, because that's where the funding comes from, is industry for industry research. So thank you very much for the opportunity to chat today. I'll just quickly sense check to see there's a lot of appreciation and thanks for the great presentation. I will talk with you, Annie, after the presentation later today. Carolyn just mentioned a great presentation. It would be fantastic to see more research and more data to support organic producers and nutritional benefits. We're certainly on that pathway, so thank you. Annie's just said interested to learn more. Sue has said thank you. I'll catch up with Annie on her second comment, and Andrea just said thanks so much to us for supporting this important work. Senaka, there's one last thing in here. Simon has sent through a question that suggested, are you able to describe the next area of research the university would like to conduct within this comparative field?
Could you please repeat, Nikki?
Sorry, I was talking very quickly. Can you please describe the next area of research that the university would like to conduct within this comparative field?
Yes, it's a great question. So what our plan is to bring some of these observations, which we sort of touch based with our review article, into the lab. To best of our knowledge, there's no any research in the world which compare organic versus non-organic food product, any type of food product, in terms of the effect on the gut microorganisms and health. So in particular, there'll be a PhD student who's going to work on these aspects. So we are going to mainly focus on some of the fresh produce at the moment, maybe with some different type of food products as the first step. But next few years, we would like to cover all these food products and answer some of the questions in this field, which has never been answered before in detail.
Excellent, thank you. And we're looking forward to hearing more about that. There's no more questions that have come in, and I guess wanted to thank you again, Anna, Senaka and Josephine, for today. We've had so many positive comments from everyone who's watching, and I think it was a great opportunity. This is the first of many to come, so we're looking forward to sharing more information in the coming years around the benefits of organic gut biome, and also the benefits of organic in general with research projects such as this. So thank you everyone for attending today, and feel free to send any of your other questions through after if you would like to have anything else answered.
Thank you.
Thanks for having us.
All right, bye.
Bye.